So I was in class the other day, well, actually a long time ago. I we were asked a question about, I think it was um income, and it had to do, you know, um this fancy little number right here, euler number, and very recently I found about Euler's identity. This one right here, where e to the I pi power plus 1 is equal to 0. Now I've got that written down right here. And I simplified this to just e to the I power, e to the I pi power is equal to negative 1. And I is equal to square root of negative 1. And if you can recall from the quadratic formula, you can assume that the square root of a variable has two solutions, a positive and a negative solution. So you square root negative 1, you get positive negative I right here. And here's my reconstruction proof right there. So let's go and draw out Euler's, or at least y is equal to, well, we're gonna get a visual representation of this. I is equal to e to the I pi power, which is equal to negative 1. For the sake of visual simplicity, let's go ahead and add a slider, see if Desmos will be cooperative. Here we go. Now we can move this up and down. Doesn't get absolutely cluttered everywhere. So, if you know how powers work and how I relates to a power, you know, so first, it's just this Desmos being understand this. See if, well, okay. Sorry for that. Desmos is being very difficult right now. But I broke this down into e to the square root of, I can find this, there it is, e to the square root, with power of square root negative pi squared. Now, if we set our full variable right there, you can see that they're the exact same. Let's go and add another slider so we can do the two. So now we have two adjustable proofs right here, two adjustable Euler's identity. It got me thinking, with it's recursive. You can, with if you power it enough, you will get itself. So I squared is equal to negative 1, right? If you're confused, I is equal to square root of negative 1. But if you can see right here, I to the third is equal to negative I 1. It just goes on and on. And I thought if you were to put this on a graph, you could put and represent it and be, whoa, hold on. It's getting funky. I remember. That e to the I to the power of 2 integer of x times pi and put a square root here. This is getting funky. Oh, that's how I mess this up. You can at least I is recursive. Well, let me redo this one. E to the I power to the power of 2 times the integer of x plus 1 pi. All this is e to the power is equal to negative 1. Again, let's add another slider. Move that out of the way. We have 3 different Euler these. But because I is recursive, you can see how it's even possible. I just think that this is really cool. That earlier I mentioned how I first saw like some kind of link between Euler's number and pi. I had no idea what it was. But we can take, say, by square root of pi, you know, getting difficult again. But it's pretty cool, you know? Um, I feel like you could really start to break down Euler's identity on paper, finally get a pretty solid link between pi and e, if you don't already find it. Me personally, I have no clue how how e came into life. This irrational number came, but if you do want to, put this into a calculator, you can. In the TI-84, you can press math, go to the right and press 5. It'll show integer. Basically grabs the integer of whatever this is, like get you want the integer of negative 2.5, negative 2, I don't know, Desmos is really weird. I don't know, I tried pressing here, didn't work, but 3 different Euler. No clue how. Um, I'm 100% sure his name was Euler. Leonard Euler, this guy. But I have no clue how he got from pi to e. Well, he had to start at pi, or else there'd be no correlation at all. So, it's just a little thing I found out.